section 2.4 here, we're going to talk about linear functions. And generally speaking, when we start talking about lines, we start talking about slope. And if you remember from way back when in your previous math courses, when you use slope, we generally use the letter M. And there was a formula for it. You thought about it as rise over run, which means subtract the y's, y2 minus y1 over x2 minus x1. Well, that's what we're going to do in this section. We're just going to call it something different because we're going to use slope in terms of word problems. And what slope is going to come from is it's going to be now called the average rate of change of y with respect to x. So whenever you see average rate of change, I always think of this because average means that you're dividing two things. Here you're just dividing the y's by the x's. Is just a fancy way of now asking for the slope. So it looks a little bit funny, but it's still just, notice, it is still just the same formula. It's still the y2 minus y1 over x2 minus x1. So it's still just the slope formula. There's nothing new. We're just calling it different. So what it does is it takes any graph and it takes the 2 points that they give you, and what it does is it finds the slope of the line between those 2 points, and it now calls it the average rate of change. So we're just using the formula for slope. So a good example is this first one. If the pitch of a roof is 1/4, how many feet in the horizontal direction correspond to a rise of 4 feet? So what they've actually done in this one is give us the slope is 1/4. So because they're already giving us the slope, they're already telling us the rise over the run. They're now saying, what if you had, instead of a rise of 1 and a run of 4, what if you had a rise of 4 feet? What would be your run? So they're saying, what would this be equal to if instead of this I had now a rise of 4 feet? What would the run be? Well, you got to treat this like equivalent fractions and say, well, how do I get the 1 on top, my original rise, to turn into a 4? Well, I'd multiply it by 4. But then I'd have to multiply my denominator by 4, which would make my run 16. 16 what? Well, notice, whatever the units are in our slope, there shouldn't be any in the final answer because they cancel. So if the top was in feet like it is here, it means the bottom also has to be in feet so that the feet will just cancel out. So what this means is if we have, like they wanted, a rise of 4 feet, then we have to have a run of 16 feet. For that ratio or slope to stay the same. Here's another one. For a constant function, is the average rate of change positive, negative, or 0? So when they're talking about a constant function, let's think about a function. Let's call it f of x. And it equals a constant, which means just a number. For example, let's say 3. What would your graph look like? Well, this looks like, well, f of x equals 3 means we've got something like the line y equals 3, which is a horizontal line. And by asking what kind of average rate of change does it have, they're asking for what is its slope. And if you remember, horizontal lines have a 0 slope. So when they ask for the average rate of change, it's going to be 0. And the idea is because it's not changing. It's not going up, it's not going down, it's staying the same. That's why its average rate of change is 0. It's not changing. Let's take a look at another one. Find and interpret the average rate of change for the following time period. So when I see something like this, when I see the word average rate of change, I'm automatically training my brain to think, oh, that's just slope. So we've got slope, which is y2 minus y1 over x2 minus x1. So let's see. Remember, whenever we have time like we do here, we always plug those usually in as our x's. So let's start out so we've got our first point, and our x's are usually time, and our y's are usually whatever else, and by time I mean time in years. And then I'll label my second point with its x and y. And now I can go ahead and plug them in. So the first thing, we always start out with y2 on top, which is, we're going to start out with the second y, which is 13.1. And that means we got to start out with its x value on the bottom too, which is 1996. 1996 minus, we've got the y and the x from the first point. Well, the y on top from the first point should be the 14.6. And over the x on the bottom should be the 1912 that went with it. Okay, so what we do notice is that points should stay as one on top of one another. You can't mix and match. Now, what I normally do here is at the end of these, I write the units so I don't forget, is that the tops were both in minutes. Let's see, we're both in minutes. And let's see, so the tops were both in minutes and the bottoms were years. But let's go ahead and do the math first. If we do the math first, it means we need to simplify everything on top first, which is the 13.1 minus the 14.6, and figure out what that's going to be. And then we can simplify everything that's on the bottom, the 1996 minus the 1912, before we do any kind of division. So subtracting the 13.1 and the 14.6 gets us a negative 1.5, and subtracting the 1996 and the 1912 gets us 84. We still have to do the division, so I have to take the negative 1.5 divided by the 84, which now gets us negative 0. Let's go out to two places, 0.2. And because this is a word problem, we do have to be careful. There are units here that we have to worry about, which is, we said that on top was in minutes and the bottom was in years, which means that once we've done the division, it's actually now in minutes per year. So whatever they were talking about with this, and it seems like it was a winning time that they're talking about, so races, is that it's going down at an average rate of 0.02 minutes per year. And that's going to be our final answer. And the most commonly forgotten thing is that you do need your units when you're talking about word problems. So we're just finding slopes, which we're calling average rates of change, and actually learning how to use them in terms of a real word problem. Here's another one. We've got the total amount spent on plasma flat panel TVs in the U.S. changed from $5,302 million in 2006 to $2,907 million in 2009. Find and interpret the average rate of change. So our first point with our X and Y is the 5,302 million from 2006. And the second point was, let's see, the 2,907 million from 2009. So we're still going to do the same thing, though. We're going to find the slope, or average rate of change, which is y2 minus y1, over x2 minus x1. And so let's see what happens. So we want to start out with the second point, starting out with the y's first, the y2, which is the 2,907. And on the bottom, we'll put our x2, which was the year, which is 2009. Minus, then the next thing on both the top and the bottom is we have to subtract the x and y for the first point. So the first point had a y value on top of 5,302 minus the year that went away along with that on the bottom was 2006. So we'll go ahead and do the math here by simplifying the top and simplifying the bottom. Let me remind myself that the top was in dollars, but it was also in millions of dollars. So I don't want to forget that. And keep my units here. And the bottom here we could see was in years. So I'm going to leave that so I don't forget. So let's do the math on simplifying the top first, which is doing the 2907 minus the 5302. Let's start out there and see what we get there. So we've got the 2907 minus the 5302, which gives us a negative 2,395. So it's a negative 2,395 divided by what was on the bottom. On the bottom we have 2009 minus 2006, which will be a total of 3 years there. So we need to do the division next. So divided by 3, we need to take those two and actually do the division, which gets us a total of negative 798. We're going to round it, and I know there's a decimal after that. You could do it as 0.33, but there's no, it's up to you. My math lab will tell you how to round. So this would be negative 798. Be careful. This was in, for units, millions per year. So millions per year. But that's our final answer and exactly what they're looking for. And again, you're just going to have to watch my math lab for how they want you to round. Keep in mind, my math lab is very particular about how it rounds. If you round a different way but still get the correct answer, they probably will mark